In this video, we are going to talk about capacitors, different types of capacitors, how to add them in different configurations, how to design them, and different presentations of capacitors. The first thing, what is a capacitor? Capacitors are one of the fundamental passive components. It is more basic form. It is composed of two conductive plates separated by insulating dielectric. The ability to store charge is the definition of capacitance. So anything that stores charges, it is a capacitor. So we have two plates. We have a space, a distance between the two plates that is going to be filled by a dielectric material or air, depending what the definition or what is the capacitance that we want. And we can vary this by either changing the distance between the two plates or changing the actual size of the two plates. So that is what capacitance. So capacitance is anything that can store energy. So here is how a charging process works. So we have a battery, we have the capacitor plates, the two capacitor plates here. So we have the battery, the electrons is gonna keep going, and it's gonna come here, the electron is gonna come to this side, and it's gonna be transferring energy. Electricity is gonna flow through it for a little time, for a specific time, depending of how fast or how slow this capacitor can charge. It's gonna start slowing down as the charge keeps building up. Once the charge is built up here, the charge of the capacitor is going to be the same value as the battery that it is connected to. Okay, this is a very basic principle, but very important principle used all across electronic component designs. So at the beginning, this is going to act like a short, and then slowly it's going to become as an open. It's going to be like an electric switch. Short for a little time, open for after a certain time. For DC circuits, this is going to be used as a switch, charging and discharging. As an AC circuit, this is going to be used as a dynamic switch. So different applications. But what is capacitance? Capacitance is the ratio of charge to voltage. So capacitance is represented by the capital letter C and is equal to the charge stored versus the voltage hold. So how much charge for the voltage I have, the ratio between this is going to give me the capacitance. Rearranging the amount of charge on a capacitor is determined by the size of the capacitor and the voltage that the capacitor can have. So depending on how big the capacitor is and how much voltage it can hold, that's going to tell me how many coulombs of charge it can keep. So for example, here it says I have a 22 microfarads. Another important thing, capacitor units are farads. Okay, so one charge over 1 volt is equal to 1 farad. So capacitor values are usually in the micros to the picofarads. Very, very small values, okay? And we are going to see later why. So the example here it says we have a 22 microfarad capacitor is connected to a 10 volt source. What is the charge? So we just multiply the capacitance times the voltage, and we get that we have 220 microcoulombs. Pretty straightforward formula. Let's analyze or an analogy to capacitance. Imagine you store rubber band in a bottle that is nearly full. You could store more rubber bands, like the charges in this case, if the bottle, the capacitance, or if the bottle is bigger. that means the capacitance is bigger, or push them into more voltage. Thus, we have the charge equals coulombs times voltage. So there are two ways you can increase the charge. You can push them together, or you can have a bigger battle. So what does it mean by pushing them together? If you have a high voltage source connected to the capacitor plates, then of course you're going to stock more charges into the same amount of the capacitor. So a capacitor stores energy in the form of electric field that is established by the opposite charges on the two plates. The energy of a charged capacitor is given by the equation. So now we are interested in the energy. So the energy is 1/2 capacitance times voltage squared. We have different representations of this energy version of it. If we go back to the formulas here, to this formula right here, if we solve for different components and then we plug it back here, we have different varieties depending if we have coulombs or we have voltage or we have capacitance. So we have energy in joules, capacitance in farads, and voltage in volts. So if we say farads times voltage squared is equals to joules. It's important that here is not power but energy that we are calculating, okay? How to design a capacitor? Capacitance of a capacitor depends on three physical characteristics, just like resistors. Resistors also depend in physical characteristics. A capacitor can be designed as follows. So a capacitor is directly proportional to the dielectric constant times the area of the plates, and inversely proportional to the distance of the plates. So these are the three components that I can play with to design my capacitor. By playing with this, I can design my own personal capacitors, and it's very easy. You just have to have the specific materials for the capacitance you want. Of course, you can buy them off the shelf, but then you'll be limited to whatever it is that they're selling you. But it's more compacted, right? When they are being machine pressed and machine prepared packaged, so it's easier for us to use than actually making our own capacitor. So, but let's do an example assuming that we would make our own capacitor. Find the capacitance of a 4 centimeter diameter sensor immersed in oil if the plates are separated by 0.25 millimeters. So they are giving us the coefficient of the dielectric to be 4.0 for oil. So since there has nothing to, in this example, we have the diameters of the plates and we have the separation. The dielectric is actually wherever the surrounding or the environment of the capacitor is going to be. In this case, is oil. So we are going to take this constant and we are going to multiply that by the area of the plates. So we have the diameter, so the area of the capacitor we are going to assume is cylindrical. So pi times r squared is going to give us our area, and then the distance we are going to put it in meters so the meters can cancel. So we are going to get that our capacitor is going to be 178 picofarads. So this is how you would design something if you were to have the specific or the physical components of the capacitor. So let's stop right here.